Hello everyone, welcome to this video. In this video, we'll be solving the next question where we have to calculate the distance between the point P and the point Q, where the coordinates of point P are given to be x1, y1 and the coordinates for the point Q are given to be x2, y2. Right? So when PQ is parallel to y-axis in the first case, we wanted to calculate the distance. So how would our figure look like? So actually in coordinate geometry or in any geometry, if you are clear with the rough sketch of what you are solving, then it becomes pretty easier for you to understand and solve the problem. Right? So here let's first of all draw our coordinate axis with this as the x-axis, this as the y-axis. Right now our line PQ is given to be parallel to y-axis, so it would be something like this, a vertical line. Hence 2 points P and Q would lie on it. Now you see here, this x distance here is exactly the same as this distance, correct? So that means the point x1 here would be equal to the point x2. Why? Because our line PQ is parallel to y-axis. Right? If that is so, if x1 and x2 is equal to each other, then by the distance formula you can substitute their values here. So you will subtract x2 from x2, which would give you 0. Right? So you have 0 square, which is just 0. You can leave this term. So you're left with the square root of y2 minus y1. Now you cannot just cancel out this square and square root. Why? Because in that case you would only have this value, right? Otherwise, if you do it like this, you only get one value. In fact, we have two values for this. Why? Because you see, if you write square root of 5 square, right? This is the term with you. So what is the answer? Is it only plus 5? Only plus 5 will give you this value, which is what? It is square root of 25. So square root of 25, is it obtained only with plus 5? No, it is also obtained when you have minus 5 with you, because minus 5 square and square root would become square root of 25 again. So the same answer. So don't just go and write down the positive value only. We have to write down the negative value as well. And a common method to do that is by writing the modulus here. Modulus here, the mod here represents that we are taking both the values, correct? So this is the first case. In the second case, we are required to calculate this distance between the points P and Q whenever our line PQ is parallel to x-axis. So when we are given this coordinate system, we have the x-axis with us, we have the y-axis with us. On this line, we have 2 points P and Q, such that the coordinates of P1 is known to us, P is known to us, and Q is also known to us. Now notice that the distance here covered by this line, this point P, in the y direction is exactly equal to the distance covered by the point Q in the y direction. So therefore in this case, the two coordinates y1 and y2, they are in fact equal to each other. If they are equal to each other, we can substitute the value in the distance formula here and then solve. So in this case, in a similar manner, you will get the answer as the mod of x2 minus x1, right? So this is the answer. So I hope you understood this question well. Well, that is it for this video. Thank you for watching.